Hello, in this lesson, I want you to write compound statements and determine the truth values of those compound statements. I want you to write conditional statements and determine the truth value of the conditional statements. We have a ton of vocabulary we're going to come across in this lesson. Statement, truth value, negation, compound statement, conjunction, disjunction, conditional statement, if-then statement, hypothesis, conclusion, related conditionals, converse, inverse, contrapositive, logically equivalent, and biconditional statements. So we're going to do a lot of vocabulary with this unit in this lesson. Not so much a lot of hard math to work on or long problems to work on, but more short with a lot of vocabulary. So let's get started here. A statement is nothing more than a sentence that we can be classified as true or false. You don't have to know if it's true or false. You just know it has to be classified as true or false. I gave you an example here. A rectangle is a quadrilateral. That's a statement because it's either true or false. In this case, it is true. But if you didn't know that, it still would be a statement. When you have a sentence like close the door, that's a direction. That's not a statement. That's not something you can classify as true or false. Now, we represent statements with letters. P, Q, and R we tend to use a lot in geometry and logic specifically. So instead of writing a rectangle as a quadrilateral, I'll put it as P. So the truth value I've talked about is either true or false. A negation is where you put the opposite in it. So a rectangle is a quadrilateral is a statement. A negation of that would be a rectangle is not a quadrilateral. A lot of times we put in the word not or we take out the word not in it. Symbolically, we put a tilde in front of it. So if you see tilde P, it means not P. So in this case, like I told you, a rectangle is not a quadrilateral. Just like compound sentences in English, we have compound statements. A compound statement has two or more statements. Usually, in geometry, they're going to be connected with the word and or the word or, kind of like you did in English with compound inequalities. If you see the little caret, that means and. So if we take a look at an example here, it says a rectangle is a quadrilateral. That's statement P. Statement Q, a rectangle is convex. So if we put this as a combined statement or a compound statement, we'd say a rectangle is a quadrilateral and it is convex. I have the word is in there twice. I don't know why I did that. So let's take a look at a couple examples here. It says, use the following statements to write a compound sentence for each conjunction, then find its truth value. Explain your reasoning. Statement P, 1 foot is 14 inches. Statement Q, September has 30 days. Statement R, a plane is defined by 3 non-collinear points. So we want to write P and Q. So we're going to say, I'm going to blow this up a little bit so I can write a little bit smaller. We're going to say a 1 foot is 14 inches. And a plane is defined by 3 non-collinear points. Now, is that true or false? This statement is false. Why is it false? Well, in order to do and, both have to be true. So if you're sitting at home and your parent says, do the dishes and take out the garbage, you only do one of them. Are they going to be happy? Well, I sure won't be happy with my kids. Both have to be true. Since the first statement, 1 foot is 14 inches, is false, that makes the whole statement false. Let's take a look at example 2. We want to do not P and R. So not P would be a foot is not 14 inches. And a plane is determined by 3 non-collinear points. This statement is true. Why is it true? Well, because 1 foot is not 14 inches. That's a true statement, isn't it? Because a 1 foot is 12 inches, so it's not 14. And then the second statement, a plane determined by 3 non-collinear points, that statement is true. Both are true, so that makes the entire statement true. Now, disjunction, that looks like an upside down capital V, and we use the word or with that one. So it is true when at least one statement is true. So if you're doing a compound statement with the word or, if the first part is true or the second part is true, if either one is true, that makes the whole statement is true. In other words, unlike and, with or, it's going to be false only if both parts are false. So if we take a look at the example here, it says Malik studies geometry, and the second statement, Malik studies chemistry. So our compound statement with or would be Malik studies geometry or studies chemistry. The only time this would be false is if Malik does not study geometry or Malik does not study chemistry, or and does not study chemistry. If one of those is true, the whole statement is true.